Welcome everybody. This is it's been a long time, but it's another session with X# subject, and today's session is about future versions of .NET. I've called it .NET Next. Most of the session is identical to what I've done in Memmingen in October, except that we have made some progress. So some manual work that I had to do in Memmingen is now no longer necessary because the latest build, the 2.14 build, includes support for the new .NET Next projects. .NET Next. So what is the session about? I want to shortly describe what .NET is and the various implementations of .NET. Then I want to show you X# with different .NET versions, performance, and how you can deploy X# apps in the future as a single exe or as a folder of files that do not no longer depend on the registry, the GAG basically. And of course, the last question is why not release it now? Okay. First, what is .NET? And Microsoft probably doesn't agree with me, but I think .NET was the answer from Microsoft to Sun's Java. Sun denied Microsoft the right to make changes to Java. They said, it's ours, you cannot touch it. Microsoft had worked on a product called J++. And as an answer to that, Microsoft decided to create its own version of Java and to make it open source. So to publish an open standard, an ECMA standard, first in December 2001, and the latest version of the standard is 2012, so it's 10 years old. And what this standard does, it describes a common intermediate language, IL, and an infrastructure, the way in which libraries can contain code. And one of the problems that .NET has is that many people have heard about .NET, but they don't really know what it is. And they thought that .NET Framework is .NET, but actually that's not completely true. Apart from .NET Framework, there are several other implementations of .NET. So I would, as a developer, I would describe .NET as something like an interface. It's not, but to give you the idea. And there are several implementations that implement this interface. So the interface in this case, a intermediate language and a file format. And the most known one is the one on the left is the .NET Framework. That's what we have in Windows machines. But apart from .NET Framework, there's also Mono. Mono was targeting Linux, and it was also an implementation of the .NET standard. Xamarin was also an implementation of .NET targeting mobile devices. Now, nowadays, Microsoft has acquired Xamarin, and it was one of the chances they had to get people from outside who also know .NET and to work together and to create something that works both on Windows and on other platforms. And the implementation, the first implementation they did that works on multiple platforms is what's called .NET Core. And .NET Core came in several versions. The last one is .NET Core 3.1. And after that, they somehow decided to change the names again, and they created .NET 5, .NET 6, and .NET 7. These are all implementation of the .NET standard, and usually programs created for one can also run on others. They will not benefit from new features, but they will work on another framework. I will see that in a minute. Okay, let's look at .NET Framework because that's the one that we all know. It runs only on Windows, and one of the problems of .NET Framework, I think, is that it's installed globally on your machine. So there are files in the global assembly cache, and there's only one active version. Usually on the modern Windows versions, you have .NET Framework 4.8 on your machine. So how what happens if you choose the target framework when developing? And well, I probably should not show you the PowerPoint. I should show you the code. So let me see if I can open. Can you see my with the Visual Studio? I hope so.
Yep, good.
It works. Okay, good. Let me close this. So when you do a new application, it's a bit slow because of the network connection, and I want to do a console project now. Let's do a console project in the over here, you choose a framework. I said before, there's only one framework on your machine. It's global. So what does this combo box do? I'll just pick one and I'll have a look at what happens. This application has several built-in references to standard components. And if you select one, try to make this, you can see that there's a path in here, and it says it links to reference assemblies, Microsoft Framework, Net Framework 471, MSBuild, or reference assemblies, Microsoft 471 system. So the 471 here is because I've chosen 471 as the framework version. Now, if I switch it, for example, to 4.8, you would expect it to switch, and it does. So now the location of the file that it links to is no longer the 471, but it's the 4.8. The folder is called reference assemblies. So what does this mean? Well, you can say that the reference assemblies are like extracts of the files the way they were when 4.8 was released or when 471 was released. So they contain all the public types and public properties of system DLL or MSBuild DLL. Actually, the reference assemblies themselves have no code. So let's have a look and go to Program Files, Reference Assemblies, Microsoft Framework, .NET Framework 471. I'm using a tool called ILSpy. Oh, it's too much in here. And as you can see, this contains types like system collections, list, or it's a generic one. That's one that many people have used. But if you look inside the code of this assembly, you see that there's no code in here. So this assembly only publishes the outer, basically the method names and the property names. The assembly itself is marked with a reference assembly attribute, which gives away that this is not an assembly that contains executable code. So if I go back here and I compile this, and then I run it, when you look in the debugger in the modules window, you will see that now the MSBuild DLL is no longer coming from the reference assembly folder, but it's coming from the assembly cache, the GAC, basically. So when compiling, I'm compiling against this reference DLL, but when running, this runs against MSBuild. So this is basically the difference between reference assemblies and normal assemblies. There's one framework on the machine, and Microsoft has to be really careful if they do a new version of the framework, so 4.8 or 4.8.1 or whatever version they come up with, that it doesn't break public properties and public methods that already existed. So they can add new ones, but if someone has compiled an app against 4.6, for example, and expect that there's a console write line with a particular, let's say in this case, a string, that should still exist, should still have to exist if you have a 4.8 assembly. So if you want to see, apart from this list here, where things are happening, you can also see. There's now, Microsoft has changed things again. There's a file in your temp folder, but Microsoft now has an MSBuild temp Robert, because the user is Robert, and this file contains the last response file, and you can see here that the last time I compiled against the 4.8 assemblies. So reference assemblies define the subset, and the problem with it is that you have to be aware what version the customer has. And if your customer has 4.6, you should enable 4.6. And I also see the other problem is that it's not always clear where the assemblies are loaded. So the assemblies can be loaded from the folder where the app is running, but they can also be loaded from the GEC. And if there's a difference between the GEC version and the local version, then you may see unexpected problems. Now, this is something that they didn't like, and I must admit, I don't like it too. So when .NET was released, it was announced as the solution to DLL hell, but the way they've implemented it, it still has the risk of DLL hell. So one of the things they wanted to solve with the next version of .NET, which is exists already for a few years, but we haven't used it yet. But one of the problems that they want to solve is this DLL hell. So Mono and Xamarin, I won't cover too much, but this is basically for Unix and mobile outside of Microsoft, bit different, and some things are not supported. You can imagine that on Unix and mobile, WPF is not supported. Mono did have support for Windows Forms, but of course, since the Unix environment looks different, the forms also look different. Okay, after Microsoft acquired Xamarin, they started to work on a single solution for multiple platforms. And the idea is that there's no longer a dependence on a GEC or a global installation. Each program can have its own version of the runtime. And so by doing this, you should have less risk of DLL hell and similar problems. So, and in the first version of .NET Core, there was no support for Windows Forms or WPF, but right now, .NET 5 and .NET 6 and .NET 7 do have support for Windows Forms and WPF. So it's actually a complete replacement of .NET Framework. However, if you create something that must run, for example, on a Linux server, then you should stay away from Windows Forms and WPF. But for desktop apps, that's perfectly fine. Okay, so earlier versions of Visual Studio or basically the MSBuild system that we used to build were only building for a single platform. Now the idea is that when they started doing this, they said it's also possible that you want to build for multiple platforms. So what they have done is they've changed the whole MSBuild support and to make it easier to work for multiple platforms and also make the MSBuild files a lot easier. Now let's have a look at that and then have a look at what we have done for X#. going to open a folder. By the way, did you know that you can open folders in Visual Studio with this menu option? And what you see then is the folder structure, and it's dynamic. So if you change something, it'll refresh automatically. In the center now, you see the old project file format that we used in X#. And as you can see, it's very verbose. It has a lot of information. Some things are basically global for the whole file, like the target framework version, but there are also things that are only for specific configurations or platforms. So you can specify that it is debugging in the debug, but these are kind of standard. Any debug app will have a full debug type and will have no optimization. Otherwise, it's kind of difficult to trace issues. The release, on the other hand, will probably always have a PDB and optimization. A constant like debug doesn't make sense in a release version, so it's not there, but it's almost always the case. So there's a lot of duplicate stuff in here, and as you can see, you also have to specify everything that you want to include, and it's also kind of verbose. And in this case, this folder has one program file, and it has to be explicitly included to make sure that it is compiled. So this is kind of verbose, but it does work. And let's just run this app. So what does this app do? It shows my hello world, but it shows you also the location and the .NET version. And inside the app, I'm doing some simple benchmarking. I'm building a string builder, and I'm building an array with 10 million entries, 10 million numbers, and we show the length of the string and the number of elements in the array and how long it took. We're also calling the macro compiler, and we do simple math, 41 plus 1. And let's not do the data yet. And the data can wait. It's okay. Let's run this. As you can see, the .NET version is 40.3.19.4.2000. It's a bit complicated. You cannot see that this is .NET 4.8, but it is. But for some reason, they didn't change the version numbers. You can see that this is running the latest X# subscriber version to 14.04. We're running 64 bits. And the dialect is visual objects. The string that created is 68 million characters, and there are 10 million array elements. And the time is 2000 milliseconds. But let's just run it without the debugger attached. And you see it's still 2000 milliseconds. And the result 42 is not a surprise. Okay, so it takes about 2 seconds to do 10 million elements in an array. I don't think that's bad, and not at all. If you would do the same in visual objects, you would get both a memory problem and because it wouldn't even have an array of 10 million elements. I think visual objects only allows 4 million elements, but before you get there, it runs out of memory. And a string of 86 or 68 megabyte also doesn't work. I don't think you can do that in visual objects. So even though it takes 2 seconds, I don't think it's bad. So what I want to show here is the old project file format, as you have seen. And now I want to show you what we have done to open to do it the .NET way. And now I'm going to another folder. No, I don't want to open a solution. I want to open a folder. Okay, this is the folder where I have a different version. And let's comment this out. So as you see, comment this out too. This is now a very easy project file. You do not see any programs listed in here, no PRG files. The default behavior is that it always includes all PRG files in the folder and below. You also do not see the location of system DLL or system core or system XML. By default, all these assemblies are available in code. Of course, it is .NET, so you have to do the proper usings in your code to make to tell the compiler that you want to use these types in these namespaces. But apart from that, it's pretty straightforward. So this now tells the compiler to use a couple of runtime DLLs, and the rest is done automatically. Okay, the program itself is the same, and the only problem that I have here is that, unfortunately, it is not so easy to create Visual Studio support for these kind of files, for this kind of project file. So this is not completely ready yet. So that's why I'm not compiling now from within the Visual Studio. So I do not open a solution, but I've opened a command prompt here inside Visual Studio. And from this command prompt, I can decide to build and as you can see, when I do that, it creates an object folder and a bin folder, and it creates the files here. You see it copying the files. And what you can also do here is simply run it. And now it runs inside the .NET console window in Visual Studio. And you can see that it's still 40.33.03.19.4.2000. And actually the speed is a bit faster. I don't know why. Maybe because this window is hosted inside Visual Studio. Some of the assemblies are preloaded. I don't know. Anyway, it's in the same time range. The nice thing about this now is that you can also specify that you want to develop for another framework. And .NET Tool knows everything how to do this. So you can simply run it and it will build it. And over here, you see that it's created a new .NET 6 output folder and also a new .NET 6 folder in the object folder with whatever it needs. And also what you see is that the same app runs and it runs faster. It runs about twice as fast. And what you also should realize now that we look at this is that we now create a .NET version of the X-console application, but the runtime DLLs that we're calling into, and in this case we don't do much, but we do have an array, which is a .X# type, and we do have usuals because the array has usual elements, and this version calls into the version function in the X# runtime. So this is actually .NET Framework code that's called from this .NET 6 app, but it works. I think it's pretty cool. To make this work, we had to do some tricks because the .NET environment has built-in support for C# and VB, and guess what? they have no idea about X#. But fortunately, they have invented a mechanism that as a third party, you can put files on certain predefined locations. And if there are files there, then these will be picked up. And that's how we tell them how to load support for the X# compiler, because you do not see any reference here to the X# compiler. So somehow this must be picked up. And the way it works is that the extension of the project file, XSProsh, is the trigger to load language support for X#. Now, like I said before, we are compiling now for a single framework. One of the things they invented was that you can have multiple frameworks. And what will happen is that MSBuild will spawn 3 child processes to compile against Net46, Net6, and Net7 at the same time. So if I build now, you will see that actually you see a restore. The restore process takes care of basically collecting some information about components that you use. And you can see that it created 3 versions of the project. One in the .NET 7 folder, one in .NET 6 folder, etc. And if you try to run now, that in this case will not work, because there are 3 versions, so you have to be specific. If we support this in the future in Visual Studio, you will have to also choose the framework that you want to run. You can do that in the debug combo box in Visual Studio. But I can say I want to run I can run against framework 6.0. You see it's still around 1 second. I can do Net46, 2 seconds, but I can also do Net 0.70. On what I've seen, the performance of .NET 7 is about the same or a bit slower than .NET 6. I suspect that there's still some debugging support in the framework 7 because it's so new, but it could also be as a result of architectural changes. Anyway, you can see that the same code now compiles in different versions, and you can make this list as long as you want. I think it's Net Core App Net 3.1. You see it builds all targets at the same time. So I think this is pretty cool. They didn't make it easy for us to support this, but now that we figured out how it works, this is great. You also see here something called generate assembly info. What this does, it tells the runtime system to generate files with assembly properties. And the idea is that you can declare these properties in your project file, and then they will automatically generate this assembly info. And it makes it a bit easier because languages like C# do not have include files, so it's a bit easier to control versions from your build system, basically. And that's what they wanted to do. In here, you see that it also generates another PRG file. Where is it? This one. This was already generated. This tells that this particular version is compiled for .NET Framework version 4.6, where, for example, this version is compiled for .NET Core 7.0. Now, some of you guys are on were beta testers of X# 2.14, and you may have seen that there was an issue with ASOL. And the reason for that is that we were including the framework attribute, the target framework attribute, also for traditional applications. So for the ones that we have now, that are, let's say, these verbose project files. And the .NET runtime detects if this framework is there, and depending on the value in this framework, chooses a different sort algorithm. So without this attribute, the old sort algorithm is used. And if this attribute is there and it's higher than a certain version, I think it was 4.5, then a new implementation of the list.sort is used. That was the reason why there were different results in asort, because asort uses list.sort in the background. So this is not just there to basically decorate your assembly, but this is actually also used by the runtime to switch behavior. So this is something that you may want to think about. And the change in the sort was because the original sort had problems when two values are equal in the source array. Then it wasn't always sorted in the same way. So they could be swapped, and the new sorting algorithm takes care of that. Anyway, you can see now that with one project file, it can create assemblies for different frameworks. Now, what I said is that it's also possible to deploy everything in a simple way with Xcopy. And let's just try to do that. And when you publish, it says, okay, I want to know which framework. And now you can see, I hope, in the publish folder that it has a complete list of files, but however, the .NET runtime is not included here. So to do that, we need to add some things. So if I add the property self-contained, takes a while, but if you look at the publish folder now, you see that it has everything it needs. Now let's prove that. I have a virtual machine running here, and this virtual machine has a test folder. I'm going to clear the test folder, and let's have a look at the virtual machine. The program files .NET folder contains a 5 and a 7 SDK, so not .NET 6. And what I wanted to show you is that I can now deploy a .NET 6 application. No, I want to go to this one. In the test folder. Now, there's a lot of files, but it is nice that you can do it. And this is now running in .NET 6, even though there's no .NET 6 on this machine, or maybe there could have been a different version of .NET 6 on the machine. And there's a main application here, XS Console. and it runs .NET 6.11. I think this is cool. Now, it's a bit slower than on the other machine because this is a virtual machine, but it's still not bad. So it's a completely self-contained folder of files. Now, let's see if we can extend the program a bit and also use more of the X# runtime. So let's try to run stuff with a DBF and also creating an index. So it also uses the macro compiler to create an index. Let's see if this works. So as you can see here, it has opened the file and created an index and shows you everything in there. So we have X# DBF support in .NET 6. Now, of course, it would be nice if it works in .NET 7 too. I can admit that in the past it didn't. But now it does. There is, however, something that you have to do. There was a question on the forum from a Foxpro developer who wanted to experiment, and that has to do with code pages. So this code already has something in here to take care of that. But if you do not put this particular line of code in there, the encoding register provider, you get a problem. And the problem is that code page support is not in .NET 7 by default, because on certain environments, they do not have these Windows style code pages. So if you want to support code pages, and which we need in the runtime, because we need to get basically the proper translation table to translate the bytes in the DBF to Unicode, then you need encoding support. And what we do here is that we have, I'm enabling this by running and calling a method which is not called when this is compiled against .NET 4.6, but this takes care of that. And you see here that I'm using an if-def for something that I didn't specify. Now, if you look in this folder, you see that the MSBuild system has automatically added a lot of defines. So it has a .NET 5 or greater, 6 or greater, 7 or greater, etc. And it's a lot. But anyway, these are there, so you can have conditional code for a certain version of the framework. And as you can see, it compiles the application against reference assemblies from the program files .NET folder. And there's a lot of them. These are the similar files that we saw in the output folder. So what you see here is that it runs X# code with DBFs, even though the X# runtime itself is not compiled in .NET 5 or 6 or 7. The .NET X# runtime files are compiled against .NET Framework 4.6, so it should run on 4.6. Are there any questions about this so far? No? Are you still there?
Yeah. I just wanted to point out that most of those DLLs are not really needed. They are needed if you do use that, for example, I saw 10 DLLs for XML support. If you're not using XML stuff in your application, then none of that is needed. So
That's
it's not, yeah, it
that's
will not
absolutely true.
Yeah.
That's true. However, if you have a dynamic language like X# that has a macro compiler, you do not always know what people are using. So I would recommend to leave it there. However, it's a lot of files to deploy. And what I want to show you now is that you can also create deploy a single file. Let me see. Now I'm building a version of X# of this project in release mode for the framework 7.0 for targeting Windows 10 x64 self-contained. So let's have a look. No, this is not what I expected. I'm looking in the wrong folder. Now we see two files. Let's go back to my virtual machine. Now I have to make sure that I include the customer DBF too, because this runs. As you can see, it now runs from an exe and a DBF, so and a PDB, but you don't really need the PDB, so you can even throw the PDB away. You can simply deploy just exe, and it's a special exe. So if you look at the exe, let's go to this folder. If you open this exe with ILSpy, you will see that this is what they call a .NET bundle. And the .NET bundle contains everything that we saw before. So over here, you see all the files that are embedded. So it's like a zip file, but then different. It includes the JSON files that somehow are needed to specify which the runtime configuration. I'm not sure why this takes so long. Anyway, it contains the versions of the X# runtime. And you can see here that this was compiled against framework 4.0. Because we do not put a target framework attribute in there, it is 4.0 as far as this component is concerned. But this one does have a target framework, and it says 7.0, so that's why it says here 7.0. But I think it's nice that you can have a single file and deploy it. Of course, the deployment will be a large file, but you know it's fully self-containing. So if I would do the 6 one, because with the 7 I could cheat. The 7 is already on my virtual machine, but this is now again a 6 version. So go back to the virtual machine.
Robert, is it a tool called to do that, to combine all into one? Or is the compiler doing it?
I don't do it. So it is the .NET tool that does it. It's a step inside. Yeah, we can sidestep this. Just let this run this and then see the 6.0 version. Okay. So what happens is that let's explain a bit of what happens in the background. So .NET, but also MSBuild from within Visual Studio sees that this is a project file of a special type and starts to pull in things. Now, if we look at Microsoft Visual Studio folder, you see an MSBuild here, and this has the normal MSBuild support, and this contains all kinds of props and target files. And there are target files for C# that specify how to call the C# compiler. Now, these files do not have support for X#. However, what is possible is that in this current folder for MSBuild, there's an imports, and there's a certain directory structure. And as you can see, what I've done here, I've copied X# before common props. So the name of this file is not really relevant, but it has to go into the import before folder. And inside this file, I'm now saying when the project extension is XSProsh, which is our extension, I'm going to make sure that there's a folder name set in an environment variable. So our installer sets this environment variable, but if for some reason it doesn't exist, maybe your colleague installed it and this is installed as a environment variable in his profile and not in this profile that you're running it, then what I'm trying to do is I'm reading the location of X# from the registry. And then in the end, this is the important one. I said there's a language targets file, and it's in the X# MSBuild directory. It's called X# common targets. So this file gets included because in this process from MSBuild, it says if there's a variable with the name language targets, I'm going to automatically include the contents of that location. And I'm also including some special properties for X# here. So this is the one that's important. And let's go to the Visual X# folder, program files, X#, MSBuild. You see the same file is here. Actually, this is where I copied it from. But it says that the X# common targets file always needs to be included. And what you see here is that in the X# common, we tell it when there's a cross-targeting build. This is what we do when you have multiple frameworks. Then a special version is included, special targets files included, and if it's not a cross-targeting build, then X# current version targets is imported. So that's what it does here, it imports it. And before it does that, it imports the managed before targets and the managed after targets. Now these files contain the magic that takes care of deploying everything and building everything, etc. Now, and this X# cross-targeting targets and current version targets are also in this folder. The cross-targeting doesn't do much, but it makes sure it basically checks something, and it imports the Microsoft Common cross-targeting targets. And this one is actually contains the instructions how we build our project. So it says here there's a task X# build XSC, and over here in the bottom you see a task XSC, and this specifies the parameters that this task gets. So basically we're passing the list of files and the output location, the compiler options, etc. to the extra build DLL, and this takes care of creating a command line. And this also contains instructions for the native resource compiler, so for the RC files. This contains a custom task to write code fragments, and this is used to write the assembly information. And so this is cool. This is all, it's complicated and it took a while, but the whole building or combining of the DLLs into, how do you say it, into one output assembly, this is done by MSBuild. So if you look here, there's a, where is it? Comment before tasks and after tasks, and it's, I would say it's impossible to understand everything. You see here is a targeting, and this basically takes care of splitting the target frameworks into separate frameworks, and then it calls a child process for each of those frameworks. And now I'm not sure, I think the main is after calls tasks that take care of things. But as you can see, there are many tasks in there, and it imports things from left to right, and it's difficult to follow. So you see here, for example, if target framework's not is empty and target framework is empty, then it sets this property. This is the property that we use to determine that it's a cross-targeting build. And there are many other things here. I don't want to spend too much time here, but you get the idea. Okay, let's go back to my PowerPoint, because I think okay, we have seen this. Okay, I think I've already covered almost everything. If people who were in Memmingen saw that I had to do something special to get this MSBuild support to run with the 2.14 release that we have released to the general public, and that is also now, or not to the general public, to the Fox, but it will be released to the general public end of this month. All that special thing is part of the normal installation. So that was one thing. And in Memmingen also DPFs in .NET 7 were not working. That's fixed. So that's something else. Why we do not release it now is the most important one is the second bullet. RVS integration needs some adjustments. The way it's not easy. If you look at where our development time is spent, I would say less than half of the time is spent on the compiler and the runtime, and more than half of the time is spent on making things work in Visual Studio. If you look at the issues on GitHub, I would say 70% or more has to do with Visual Studio, the editor, the project system, etc. So Microsoft doesn't make it easy for us, but we do want to support Visual Studio. And the other bullet is, if we release it, we also want to deliver the runtime compiled for the various frameworks, so you get a bit better performance. So yes, those are the reasons why we don't release it now. Okay, how am I doing on time? Oh, it's an hour and I'm almost, I'm done basically. Do you have any questions? No, maybe I can show you something. Yeah.
Hi, it's Basil. So you said the project file was really simplified, which is the case now. But where can you set all the switches then, like /vo10, or you know the constant that you will define in a
debug? I understand the question. Yeah. If we do this in Visual Studio, we will give you a properties dialog just like you have now. You can set the switches, but of course all switches are in here. So if you would do VO7, this will already compile with VO7. So this file contains values and I should say properties, and these properties are passed to the MSBuild DLL, which takes care of creating the command line. So we will have to add a property page for the project properties where you can specify this. And one of the reasons some people have noticed is that originally we had one Visual Studio DLL, but at the moment we have already split up the language service in a separate DLL, the app designer, which is the name that Microsoft gives to the component that takes care of the project properties, is also in a separate DLL, and the project system itself. The reason why we split this is because we want to share the app designer between I would say the new project system that takes care of the simplified files and the old one. So but it goes in the file in XML format.
Okay.
So if you do this and I compile, by the way, I could also call MSBuild, but I'm doing .NET Build because .NET Build takes care of calling NuGet to extract packages. Now, if you look in my temp folder, where's my MSBuild Robert? You can see that it should now contain /VO somewhere. No, this is strange. I expected that. I think we found a problem. Yeah, now it is. Okay, true is apparently case sensitive. Now it includes VO7. Normally there's not a problem because this gets generated, but so this is case sensitive anyway. I should change that to make it that it also works with the lowercase true. So yeah, this is what our application pages will do. If you look at a C#, one of the changes also is that you can now edit this project file without actually unloading it, which is also new in the C# project system, which we will also support that in our .NET simplified version. But over here you see some properties, and if I go to the property pages, they have redesigned this because it's now one huge page basically. And this is just like bookmarks on the page. So if you specify something here, let's say a target OS, it says now .NET 6 Windows. If I target it, I have no idea what TV is, but it compiles it for TV OS. So what you enter here gets saved in there, and we will do something similar. So one of the things we will also do is add the support for global usings, which means that you do not have to put usings in every file. And what C# does, if you look here, and I'm going to build it. It creates, where is it? A compiler generated global using, we will do something similar. So you do not have to clutter all your code with usings. Some things you want to use everywhere, like, well, they have a list here, system.io, system link, etc. And these will then be available in all your code. Anything that you put in here will go in there. Apparently, these are the default ones. So you do not see them in the file. These are set somewhere else, but if I change it, now it includes the no one, and now it also includes these conditions, because these are specific for different compiler options. And you can specify here if you want to use it for all or value, and then you can have these separately. And you see that it works. So we will do something similar. That answer your question, Basil?
Yeah, and more.
And more, yeah. Sorry, I get carried away. That's not what always happens. Anyway, but the whole mechanism of C# or .NET compiling things works the same for C# as for our language. So if I build here, and I think in here you can specify that you want to create a NuGet package. We will put that in there too, and this will always all be in there. I'm not sure about the analyzers though. Okay. Other questions? If not, I want to show one more thing. Not something that I invented myself, but I saw that in Germany. One of our speakers showed that, and I think it's nice, so I want to. So what I have here is a Blazor app, which is a web app compiled against .NET 6. I have a class library with, this is a modern class, but this also has a FoxPro style class and something else. This is also a modern style. And this Blazor app has a reference to a class library. And I've added a few pages there that show data from this class library. Let's just run it. I hope it still runs because I haven't touched this, but this. Okay, well, this was for VirtualFox, as you can see. This is standard Blazor sample and a counter and a fetch data. But this now, actually, let's put a breakpoint in there. I'm not sure what, I think it was this one. Yeah, so it goes from the .NET 6 Blazor UI into an X# application and gets the information. Or in this case, it loads a list of employees from a SQL table. Actually, the loading there, it is not that slow. I put a wait in there. Where is it? it is fast. So this will connect and get the data from a local machine, the employees table from the Northwind. So what it does in the background, inside this page, I'm calling a method get employees, which returns a list of employee objects. Actually, it's specified as an I list, and then it adds employees from a SQL table using the FoxPro SQL Exact, SQL String Connect to connect to the database. And this list now, so it says for each emp in employees, and it displays the information. And the employees is filled in the uninitialized with the list of employees retrieved from the database from the X# code in Fox syntax. So I think it's kind of cool that we support callbacks into the FoxPro code. Oh, now it stops in a breakpoint. So it's kind of cool that you can have a .NET app with Blazor, and this is full. This also works. So this is like say the layout works on it's device independent. Basically, you can see that it changes the UI based on the size of the window. And well, it's too far now to give you a complete description of what Blazor can do. But what I think is interesting in this case is that we can have an assembly that's running in a web environment. Now, what is important to realize, there was a customer on the forum without asking a question, is that if you use DBFs like this, then it has the same problem that we saw before with the .NET 6, is that code page support is not there. Also, there's no current folder, basically. So you can probably get this to run on your development machine with a hard-coded folder to the DBF files, but on a web form, you probably don't have that luxury. You cannot run the app in such a way that it can access the local hard drive. So the best choice here is to basically use SQL database and use a connection string that to connect it to the database. But you can have your business logic and expose it through Blazor. Okay. Other questions? Wolfgang would like to use .NET 6 and easily switch. Yes, you can. What the best thing would be is that we deliver you the X# runtime for .NET 6 or .NET 7 in a NuGet package, basically. And
Robert,
I know
that's an XID question. We had a conversation there.
Oh,
So,
yeah. Yeah, well, I'm not sure, but Chris, if you compile in XIDE, you only have a choice for CLR2 and CLR4.
That's a remnant from the Vulkan days. It's not.
Yeah, but does that mean that if you compile in XIDE, that you always compile against the GAC version or the version from the Microsoft.NET folder in Windows?
By default, you're compiling against the GAC. But if you want, of course, you can target the reference service.
Okay. Yeah. So you can target, but you have to do some extra work to get the reference files from that folder.
Yeah.
Well, in Visual Studio, that MSBuild takes care of that. MSBuild figures out that now I'm running against 4.8, so it gets the right folder. It would be nice if you could do something like that. But it's a lot. It's a lot of work. You need to. I think there's a lot of locations hard coded in there to make this work. For those of you who are still on the public build, the 2.14 that will come end of this month has now, where is it? The new add references dialog. Some people have asked for it. I think it's nice there, and you can search here on the proper way. So you can say sharp, and you can find all the files there. So I think it's kind of cool. Okay. Any other questions? No? Then I think it's time to wrap it up. Thanks a lot for your attention. It is, I hope there's something in there that you can use. If you want to know when is the .NET 6 and 7 support Visual Studio ready, we hope in March or before that. But it is really, someone complained about documentation. There was a lot of documentation on Exchange. Well, this is an area where there's no documentation at all. So there's probably internal Microsoft documentation, but they're not really helpful here. So we have to figure it out all ourselves. And yeah, it's a lot of work. Okay. So guys, I would like to finish now. Any last questions? Okay, cool. Thanks for your attention. And I will probably be posting this online. It takes some time to process, but probably tomorrow. So others can view this as well. Thanks a lot and stay safe.